All right, so we're going to look at going through our linear functions homework. So the first thing we want to do on number 1, it wants us to graph. That's a linear function because there's no nothing like x squared or absolute value of x or square root of x. It just has our x and our y. So it says to identify the x and y intercepts. So to find the x intercept, we're going to let y equal 0. And so if we do that, looking at this equation, it'll end up negative 3x plus 4. We stick a 0 in, right, for y. And this is equal to 12. So we'll have negative 3x is equal to 12. Divide both sides by negative 3. We end up that x equals negative 4. So I know negative 4, 0 is my x-intercept. Similarly, for the y-intercept, we're going to let x equal 0. Because we're not moving left or right any, we're staying on the y-axis. So if x is 0, we're going to have negative 3 times the 0 this time, plus 4y equals 12. This is going to be 4y equals 12. Divide both sides by 4. We get y equals 3. So again, let's see, 0 for x, 3 for y. That is my y-intercept. So my x-intercept is negative 4, 0. I plot that on my graph. There's negative 4, 0. My y-intercept is 0, 3. I plot that on my graph. And then I can connect the dots, and that would be a graph of that linear equation. That's one way. Another way we could do that is to put it into slope-intercept form. So we had negative 3x plus 4y equals 12. So remember, slope-intercept form is y equals mx plus b. So if we can rearrange this equation where y is by itself, we'll have it in that form and be able to identify the slope and the y-intercept. So we're going to move the x over, or the 3x over, and we'll have 4y equals, I'm going to write the 3x first, so it's starting to look more and more like the form we want. Divide both sides by 4. And we're going to get y equals, well, this 4 goes over under the 3 and also under the 12. So we're going to get 3/4 x plus 3. So now we have that my slope is 3/4, which is going to be the rise over run. And I have my y-intercept is 3, or we'll say 0, 3. So I go and plot my y-intercept, my 0.03. Then I'm going to use my slope, which is 3/4. So up, 1, 2, 3, run 4, 1, 2, 3, 4. And so you only need 2 points to determine a line. You can keep doing that pattern, going up 3/4, or you could even go down 3/4. And you can see there I get that x-intercept that we found in the previous problem using that other method. So it should look exactly the same. The picture should be the same. It's just 2 different ways to do that. All right, so next we want to find an equation of a line that has to pass through these points. So point slope form, that's the one where we have our y minus y1 equals m times x minus x1. And so for that point slope form, we need a point, that's our x1, y1, and we also need a slope. There's a couple different ways that you can calculate the slope. You could plot both of those points on a grid, or you can also use the slope formula. I think it's a little bit easier just to kind of think about what's happening. And what I mean by that is I know the point 1, negative 1 would be about right there, and then negative 7, 3, 1, 2, 3, 4, 5, 6, negative 7, up 3, it's somewhere over there. So I just want to think about how much I have to rise up and go over. That's really what my slope is. So if I'm at, if I'm thinking about the rise part, my rise, if I'm at a negative 1 and I'm rising all the way up to, this would be 3, so I'm looking at the difference between negative 1 and negative 3, which is negative 4. For the run part, I want to know how much I'm going left and right. So that's from negative 7 to positive 1. So I want to know the difference between negative 7 and 1, which is going to be a negative 8, or 8 spaces. Now I do notice that I have 2 negatives going on here because my my points, if you kind of look at it, if I draw a rough line, that has a negative slope. So I kind of messed up on my signs, but that's okay. So I know that, let's see, how did we write this down? If you want to use the slope formula, that's x1, y1, like my first point, x2, y2, that's my second point. And so when I write that -7 minus 1, that's looking at these x values. And then when I write the top one, 3 minus -1, if I had paid attention to the order, I would have written it as 3 minus -1, which is +4. But again, it doesn't matter so much as long as you understand how many spaces that you're moving, and then we know the difference in those slopes. So we have a negative slope, positive slope, slope of 0, and undefined. So if you keep those in mind, you don't have to worry too much about that formula or keeping your signs straight. We just know that we'd have a negative slope. And so when I wrote my rise over my run, it's going to end up being 1/2. If I rewrite, let's rewrite that over here, so that way we can keep track of those signs a little bit better. We're going to have, that'll be +4 if we write it with 3 minus that -1. So just doing the difference between those gets us that 1/2 as our slope. And then you could pick either one of the points that you want and plug it into that formula. So the formula will say y minus, I'm going to use just the first point. We're going to say 3 equals 1/2. X minus -7 becomes x plus 7. We need to add in the little -1/2 on there. Okay, in order to find the slope-intercept form, remember that's the one where we have y equals mx plus b. There's really two ways that you could find it. You can use the equation that we just made up, and because we need to find a slope, which we already have is -1/2, and we need to find a b. So to find that b, which is the y-intercept, we could plug a 0 in for our x's and calculate y. Or we can use one of the points that we have. So if I look at the point, I don't know, it looked easy, 1, -1. We can plug this in for our x and our y here and then find the b. So that would look like -1 equals -1/2 times 1 plus b. So that's -1 equals -1/2 plus b. So if I add a half over, then that will be a -1/2 equals b. So I already know my slope is -1/2, and my b happens to be that also. That's fine. We're going to get y equals -1/2 x minus 1/2, which is, again, the same equation that you should get if we had done the alternative, which is plugging a 0 in for that. They're both fine. So then the next thing that we have is standard form, and really that's just taking this form. I think that's kind of the easiest one to go from, and we want to write it in this ax plus by equals c, and a, b, and c are not fractions. So the first thing I'd want to do is clear the fractions. So if I multiply everything by 2 in that equation, that would be 2y equals -1x, because it would make that 2 on the denominator cancel, and then -1. I need to have my x and y's on the same side, so I'm going to move the x's over. And really that's x plus 2y equals -1. So again, that's the standard form for that equation. For number 3, it wants us to look at that standard form, ax plus by equals c. And notice it says b doesn't equal 0, because that would really just be a vertical line then, because we just have x equals some number. But it wants us to know the slope, x-intercept, and y-intercept just by using that form. Well, if we're in standard form, we can figure out the slope and the y-intercept by writing it in the form y equals mx plus b, which means put the y on one side of the equation by itself. So if I want to do that, I can take that equation and I'm going to move the ax over, just kind of manipulating some variables around here. by equals -ax plus c. Divide both sides by b, we end up that y equals -a over b x plus c over b. What that does is leaves our slope as -a over b, so that was one of our questions. And our y-intercept is going to have a y-coordinate of c over b. So that's 0, c over b. And then lastly, it wants us to have an x-intercept. And so there's a couple different ways that we could find our x-intercept. Probably the easiest is going back to our original equation and put a 0 in for y. So to find the x-intercept, we're going to take ax plus b times 0 to get c, which will end up just being ax equals c. So that means that x is equal to a over c. So our x-intercept will be a over c, comma 0. So what this is kind of showing you is we can have these little formulas. If we have an equation written in standard form, we can identify the intercepts and the slope by kind of just sticking in if we know what our a, b, and c are. And you could check that with our last problem, see if that works. All right, and for this last one, it wants us to look graphically at what's going on here. So the first thing that we want to be able to do is say, when are these two equations equal? Well, they're equal right at their point of intersection, which happens when x is equal to 1. Now the next thing it wants us to do is figure out where our graph 2x plus 4 is less than the negative x plus 1. So 2x plus 4, the place where it's less than, well, that's this green or this red graph. I'm going to cover it in green. It's less right here up until we get to that intersection. So that means that we're going to have that happening from negative infinity all the way up until that 1. And I'm going to put a parenthesis on there because we're not going to include that value. For that next part, we want to know when that 2x plus 4 is greater than or equal to negative 1. So that 2x plus 4 is greater than or equal to right here because it's above that line. So that's happening from negative 1, and this time we do have equal to, so they could equal each other, which we already know from that first part. So I'm going to put the bracket at negative 1, and then that's going to go on forever because they're never going to cross each other again. So we use the graphs by just kind of seeing and comparing them. So if we're looking at less, we want to know which one is below or when it is below. And when it's greater, we're looking about when it's above. All right, to use algebra, well, that's just going to help us kind of double check what we have going on here. And so just solving this equation, I'm going to put my x's on the side over here. We're going to get 3x plus 4 equals 1. Subtract 4, we get 3x equals negative 3. Divide by 3, we get x equals negative 1. So we know this is the point where our graph showed they intersected, and then just solving using algebra, we got that as well. Again, it's just kind of the same steps going on here. The only thing different when you solve an inequality is that the sign will flip if you divide by a negative, but we don't have that here. Or if you multiply by a negative. And so we're going to have 3x plus 4 is less than 1, minus 4, minus 4. We get 3x is less than negative 3, divide by 3, x is less than negative 1, which x is less than negative 1 is the same as the interval negative infinity to negative 1. So those are both the same. And the last one is going to come out to be exactly the same, except the inequality started as greater than or equal to, and we know we're going to get negative 1 as our result. And that means negative 1 to infinity if you're writing it in interval notation.